welcome to True Projects. In this video, we are going to explain about a project titled Brain Tumor Classification using Transfer Learning. The primary introduction of this project is to create an advanced and effective brain tumor detection solution. Through the utilization of the transfer learning, the project centers on harnessing the capability of pre-trained deep learning model to extract the crucial feature from the brain MRI images. By refining this model on the dataset of the brain tumor images, the system can accurately categorize the tumors into distinct groups such as of benign or malignant. This project aspires to bring about the transformative impact on the brain tumor diagnosis, empowering the medical professional with a dependable tool for the early detection and the personalized treatment strategy, thereby enhancing the patient outcome and the brain tumor management. By combining the state-of-art technology with the domain expertise, this undertaking holds the potential to revolutionize the field of medical imaging analysis and evaluate the standard of care for individuals affected by the brain tumor. And the primary aim of this project, utilizing the ResNet 50 algorithm, is to create a precise and efficient brain tumor detection system. Through the implementation of transfer learning with the ResNet 50, the project seeks to harness the potent feature extraction capability of this pre-trained deep learning model. The key objective involved fine-tuning ResNet 50 using a brain tumor image dataset, enabling the accurate classification of tumor into distinct categories. By adopting this approach, the project endeavors to significantly enhance the brain tumor diagnosis accuracy, facilitating the early detection and empowering the medical professionals with a valuable tool for making well-informed treatment decisions. The successful implementation of this system holds the potential to improve the patient outcome and the management of the brain tumor, ultimately raising the standard of the care for individuals impacted by this critical medical condition. These are the basic requirements that are needed to build this project. Software requirement: Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, essential Python libraries such as NumPy are used for numerical computation, Pandas for data manipulation, Matplotlib for data visualization, and TensorFlow and Keras for the deep learning task. And the second one is importing the dataset. The dataset comprises a collection of brain MRI images acquired from various sources and annotated with the tumor or not. The images are pivotal for training and evaluating the brain tumor classification model using the transfer learning. And the third step is image pre-processing. Before feeding the MRI images into the model, pre-processing steps are applied to enhance the data quality and prepare it for efficient training. This includes resizing the image to a consistent resolution, normalizing to ensure the pixel value within the certain range, and the data augmentation technique to increase the dataset size and improve the model generalization. And the fourth step is building the model. In this project, the ResNet 50 deep learning architecture is selected as the backbone model for the brain tumor classification. ResNet 50 is renowned with its deep layer architecture, enabling it to extract the intricate feature from the images. Through the transfer learning, the pre-trained ResNet 50 model is fine-tuned on the brain tumor dataset to adapt its knowledge to the specific task of the brain tumor classification. And the next step is training the model. The fine-tuned ResNet 50 model is trained on the pre-processed MRI images to learn the pattern and the features associated with the brain tumor. During training, the model parameters are adjusted to minimize the classification error and optimize its performance on the brain tumor dataset. And the sixth step is user gives the input. To make the system user-friendly, a web interface is developed using Flask, a lightweight web application framework. The interface allows user to upload their MRI images directly for the brain tumor classification. And the next step is the given input is pre-processed for prediction. The images are pre-processed to ensure the compatibility with the trained model similar to the training data. The input images undergo resizing, normalization, and the necessary pre-processing step. And the eighth step is trained model is used for the prediction. The pre-processed MRI images are passed through the fine-tuned ResNet 50 model for the tumor classification. The model leverages the latent features to predict whether the tumor is present or not, providing a valuable diagnostic result to assist the medical professional in the decision making. And the last step is final outcome is displayed. The model prediction along with of information and the visualization are displayed to the user through the web interface. The final outcome aids the medical professional in diagnosing the brain tumor accurately and making the informed decision about the patient treatment and the care. This project has the potential to significantly improve the brain tumor diagnosis efficiency and provide the more precise healthcare solution for the patient with a brain tumor. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The dataset folder containing of the No and S folders containing of various MRI images within it. And the output folder containing of the training and valid folders, and the sample folder containing of the images that will be used to test the performance of the model. And the static folder containing of the folders like images, uploads, and of CSS and the JavaScript folders within it. And the template folder containing of the HTML documents. It includes of graph, home, index, notebook, result, sign in and sign up pages within it. And app is an py file which likely contains the algorithm's information that related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains a combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the sign up is a DB file which appear to be the database file used to store the user information. And the ResNet is an H5 file which contains the deep learning algorithm information, and it is loaded into the project code during the time to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the overall code is present in the IPYNB file as a combination of graphs and output all in one place. And to execute the project, first we need to copy this code folder path and then open the Anaconda prompt. Here first we need to change the location of the disk to F because our code folder is present in fdisk. Then write a command that is cd space and paste this code folder path. By this it will change the directory to the code folder's path. And then click on enter button. After this we need to write a command that is python space app.py. By using this command it will execute this Python script and perform a runtime check for any syntax error or logical issue. By running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this address and paste it on any of the web browser of our choice, and I prefer to use Google Chrome. And then click on enter button. Here we can see that This is the page contains of the title and home and sign up buttons. Click on the sign up button. Here we redirected to the registration page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it redirected to the sign in page containing of username and password, and these details need to be filled. And I'm entering the username as admin and password too. And then click on the login button. Here it redirected to the index page containing of the home notebook sign out buttons with of choose file and upload button. Here click on the choose file button. Here we redirected to this folder containing of various images within it, and select any one of the image and then click on the open button and click on the upload button. Here it redirected to this and that detected as brain tumor. In this way, we can detect the brain tumor by using the ResNet 50 model. And here click on the try again button. Here we redirect back to the index page containing of the choose file and upload buttons. Here click on the choose file and select any one of the image and then click on open button and then click on upload button. Here the result page is redirected, and here the predicted result as of no brain tumor is detected. In this way, we can detect the brain tumor by using the transfer learning. And in conclusion, the project has successfully achieved its objective of developing an accurate and efficient brain tumor detection system, leveraging the ResNet 50 algorithm and the transfer learning. The project demonstrated the power of pre-trained deep learning model in extracting the essential feature from the brain MRI images. The fine-tuned ResNet 50 model effectively classified the tumor into having or not, providing the valuable insight into the medical professionals for the early detection and the personalized treatment planning. By improving the brain tumor diagnosis, accuracy, and streamlining the decision-making process, this project contributes significantly to the field of medical image analysis and holds the great potential in revolutionizing the brain tumor management, ultimately leading to the better patient outcomes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.